solution. Solutions have to do with vapor pressure, boiling point, elevation, freezing point, depression, and all those things. Sometimes you're given different information to solve for a unit that you know. Let's look at this question. A solution contains 3.75 grams of a non-volatile pure hydrocarbon in 95 grams of acetone. So stopping there, the non-volatile pure hydrocarbon, that's my solute. And the 95 grams of acetone is my solvent. The hydrocarbon is going into the acetone. The boiling points of pure acetone and the solution are 55.95 degrees Celsius and 56.50 degrees Celsius. So T pure of just acetone is 55.95 degrees Celsius, and T solution, what's elevated, the contaminated sample you could say, is 56.50 degrees Celsius. The boiling point constant of acetone, so Kb, is 1.71 degrees Celsius over m, where m is molality, and molality is equal to moles of solute over kilograms of solvent. Now you can ignore the other constant given here. So, what is the molar mass of the hydrocarbon? Well, you want to know the molar mass of your solute. So if you think of all the factors that you're given, the only equation that at first makes sense to use is the boiling point elevation. Well, my delta TB I know is going to be the solution, that's elevated temperature, minus the pure boiling point temperature. And that will equal my M, because I don't know my M, and my Kb. So in the end, I want molar mass. Well, the unit for molar mass is grams over mole. Well, I have grams that I can use, and I have the grams of the solvent. So I need to get moles of the solvent by itself. I know that I can get moles of solute from my molality equation. So what I'm going to do first is isolate for molality. So if I divide both sides by the Kb constant, I get that M is equal to 0.321 moles over kilogram. All right, well, since I want molar mass, I want to have moles, but I need to get rid of kilograms. Now, do I have the right information to do so? And yes, I do, because it's mole solute over kilogram solvent, and I have the amount of my solvent. I have 95 grams, which would just be, if you do your conversion, 0.095 kilograms. So if you multiply that by 0.095 kilograms, you cancel out your kilograms of your solvent and find out how many moles you have. 0.03055 moles solute. Well, since you want molar mass, that is equal to grams over mole, and you have both those values now. 3.75 grams over 0.03055 moles, and you get 120 grams with the proper significant figures. So knowing that you can use this equation many different times just by units. You can solve it for one of the temperatures, the constant, or you could solve it for the molar mass of the solute or the solvent, just knowing and remembering that it's moles of solute over kilograms of solvent.